Let's do section 11.2, page 552, exercise 31, which reads, a particle travels in the plane with position vector r of t. Find A, the velocity vector v of t, and B, the acceleration vector a of t. Now we need to remember that that velocity vector v of t is going to be the derivative of the position vector with respect to time, and that the acceleration vector a of t is going to be the derivative of the velocity vector with respect to time. We also need to remember that the x and y directions are independent of each other and do not affect each other. So we can basically just take the derivatives separately for each component. So v of t is going to be d by dt of the position vector. So we have our x term, which is t squared plus sine 2t, comma our y component, which is t squared minus cosine 2t. And then I'm just going to take the derivative term by term. So I'm going to have 2t plus 2 cosine 2t. Remember that we need to pick up this extra 2 when we use the chain rule. And then I'm going to have 2t plus 2 sine 2t. And that's going to give me my velocity vector. And my acceleration vector is just taking the derivative again. So I'm going to have a of t is going to be the derivative of v of t, and I'm just going to take the derivative term by term of the components of this vector up here. So we're going to get 2, not comma, but minus 4 sine 2t, comma 2 plus 4 cosine 2t. And those are going to be the components of my acceleration vector.